All right, Unit 10 has some awesome exploration into circles, segments in circles, parts of circles like the arcs or sectors. We're going to be dealing with diameters and radii, tangents to the circle. So there's a lot of vocabulary that we're going to explore, some of which is already familiar, some of which is going to be brand spanking new. Our goal in this first lesson is to focus on arc length. Our part 2 of lesson 10.1 is going to deal with the area of sectors. We're not going to deal with that in this video. So the first part is, let's just kind of get our bearings on some of the key vocabulary and key ideas when dealing with circles. So a circle, you know what it is functionally. Here's what it is formally. It's the set of all the points that are equidistant from a given center. All right, they are equidistant from the center. That distance, that segment that is that distance is the radius, right? That distance from the center is uniform throughout the entire circle. All right, and the radius has an endpoint on the circle and an endpoint at the center. A diameter goes through the center from one side of the circle to the other side of the circle, so it's basically 2 radii. And then a central angle is an angle whose vertex is at the center of the circle. So angle CPA is a central angle. Angle APC is a central angle. Angle CPB, notice how P is the middle letter in all of those angles. Those are central angles because the angle's vertex is at the center. In this diagram, so have that picture along with these definitions, we will name the circle based on the point at the center. So this is circle P, so we would draw a circle with a dot in the middle and capital P, denoting that this point is the center of that circle. Radii examples here are PC, PA, PB. You can obviously name these segments forwards and backwards like we did back in Unit 1, so we're going to continue with some of that same notation we did back in first semester. A diameter, on the other hand, is the whole way across, so AB or BA. Remember, when we're naming a segment, we just use the end points, so we won't call that APB, we would just call it AB or BA. All right, and it's a segment that's going forever and ever. And then central angle, I already mentioned a couple of those. All right, including the straight angle APB. All right, that is a straight angle. Its measure would be 180 degrees, and that's going to be useful information for some of our work in this unit, and in particular today. So this is some key vocabulary around circles. There's also new vocabulary. So this should be all, for the most part, things that you know already. This is brand new, but maybe not too hard of a stretch. And this is definitely new stuff. So an arc. An arc is determined by 2 points on the circle. So arc AC or CA is referring to the same arc. Arc CB is also an arc. You can also have big arcs like CB all the way across to A. CA is different than CBA. ABC is the same as CBA, and AC and CA are the same, but again, differentiating these two from these two is important. These two, we should notice they make a complete circle. They make a complete circle. So if I were to find the measures of these arcs, which is our point today, our focus today, we're going to be able to find the measures of those arcs. We're also going to find the lengths of those arcs, and those are going to be different concepts. So an intercepted arc is part of a circle that lies between 2 segments, rays, or lines that intersect the circle. A minor arc is smaller than a semicircle. So here I didn't define a semicircle, but a semicircle you know is half of the circle. So this is half of a circle, that is half of the circle. If we want to name a semicircle or a major arc, you'll notice that the difference between these is that there's 3 letters involved versus 2 letters. A minor arc is less than a semicircle, and so this is a minor arc, and so we're only going to use 2 letters. This is a minor arc, so we're only going to use 2 letters. Whereas going from C all the way around to A would be a major arc, and so we have to use 3 letters. All right? And likewise, a semicircle, we're going to add this to the list there, but a semicircle, we will use 3 letters. Semicircle would be arc ACB, and that needs 3 letters. So make sure you add that to the notes. All right, the measure, this is the key idea here, the measure of the central angle at P is going to equal the measure of the arc. All right, so that way we can sort of couch the idea of measuring an arc in terms of stuff that we already know, namely measuring angles. All right, the measure of a central angle is equal to the measure of the intercepted arc. So in this case, the measure of angle APC is going to equal the measure of arc AC. So if I tell you that the measure of this angle is 30 degrees, then I know that the measure of this arc is also 30 degrees. All right, example. If this measure is 30 degrees, then the measure of angle APC is going to equal the measure of arc AC. We put the little m in front of the arc to denote that we're talking about the measure, and therefore that will be 30 by substitution. If the measure of arc BC is 150 degrees, then what is the measure of this arc? Well, it should be the same, right? The measure of arc BC is going to equal the measure of angle CPB. And so 150 is going to be the measure of angle CPB. All right? This is the thinking. Now, how much work do you have to show on that? Okay, hopefully not much, if any. All right, if you just want to write that the answer is 30 degrees, and that's great. That means you understand the concept. But I'm writing this out so that I can communicate that if this is true, and if these are the same, then these are the same. All right, using either transitivity or substitution. And here are a couple key ideas to make sure that we understand what we are dealing with. I don't want to make too many assumptions that you get or understand, and so I want to make sure that I state these sort of overtly and outright. You can apply angle addition postulate to arcs. We would just call it the arc addition postulate, right? If we are adding the measures of those central angles, and we know that the measure of those central angles are equal to the measure of those arcs, then we can do the same thing with arcs, all right? Add the parts to add up to the total. All the way around the circle is 360 degrees. Half of the circle is a semicircle, so the measure of a semicircle's arc is 180 degrees. We're going to use 3 letters for semicircles and major arcs, 2 letters for minor arcs. Congruent central angles will intercept congruent arcs. So if I have 2 angles that are, like, let's say vertical angles, let's say I have 2 diameters here. This angle and this angle are congruent by the vertical angles theorem. That means that this arc and that arc are also congruent to each other. That's useful information, applying concepts from first semester. I know that might be making you a little nervous when we're talking about vertical angles and, oh, I haven't had to think about that for a couple months. That's all right, it's still true. Just because you haven't thought about it doesn't mean it's not true anymore. Just, you know, we're gonna be reminded of it. And angle addition postulate, that might stress you out from first semester, but we're just adding to get a total here. And so we should make this as easy as possible. Let's try to make it easy. Let's try to recognize where it's difficult, but then also make it easy on ourselves if possible. And so here we have a situation where we are given a diagram, so draw that diagram, this is example 2. We're going to find the measures of these arcs and central angles. O is the center here in this circle. And so our goal is to make sure that we can find the measures of these arcs and the measures of these angles. I'm going to do a couple of these and I'm going to ask you to do the rest. If I know the measure of this angle is 32 degrees, I know the measure of this arc is also 32 degrees. This arc is going to equal this measure, this angle measure, and so we know that that's 32. You don't have to write this, but this is the thinking. This is how I know that this is 32 degrees. Arc BD, all right? Well, if this is 32 and this is 58, then I can know, and this is important, I do want you to write this out. The measure of arc BD is going to be the measure of arc BC and the measure of arc CD added together, all right? So that means I have 32 and 58, which are going to add up to 90, all right? Which means that that big angle BOD is going to be 90 degrees, all right? The measure of arc ABC, you should notice that AC is a diameter, and so this whole thing is a semicircle. ABC is a semicircle, and its measure is 180 degrees. I would like for you to finish these, all right? You're going to try your best on those for you to finish. Example 2, you finish. Pause the video if needed while you finish that. And then we're going to talk a little bit about circumference, a little review here of circumference. And the direction that we're going is that we're going to find arc length as a fraction of or a percentage of the whole circumference, all right? If the circumference is 2 pi r, that means that we can, if we know the radius, we can know the circumference. If we know the circumference, we can find the radius. We are going to do something a little bit different than how you approached it in middle grades. We are going to leave our answers in terms of pi, meaning we're going to treat pi like a variable. We're going to treat it like x. And so if I know that I have 2 times x times some number, I'm going to get some number of x's. Likewise, we're going to get some number of pi's. So find the circumference of a circle with this radius. I'm going to write my formula down. Writing the formula helps us know the thing, all right? Which means that we have 2 times 5 times pi, we get 10 pi centimeters, all right? We're answering in terms of pi. Pretend that pi is a variable. It is a variable. It is a symbol that represents the value of a number. We are not going to approximate. We're not going to use the pi button in our calculators. We're not going to use 22/7 or 3.14. We are going to use pi as a variable. Find the circumference of a circle here. I would like for you to do this. Write down your formula, plug in your numbers, and compute the number of inches for that circumference in terms of pi. In terms of pi. Again, pause the video if you need to do that. Hopefully you're writing the answer as I speak. It's not too difficult to do that computation. But again, if you're having trouble with it, then we need to know. So if I need to explain something different or better, we can do that. All right, so the length of an arc is related to its measure. If we understand that the length is a fraction of the circumference, just like the arc measure is a fraction out of 360, we could cross multiply to solve, essentially is what we're doing. We have a proportion we can cross multiply to solve. Instead of doing this all the time as a proportion, we're going to write it out as a formula, recognizing that the arc length, which I'm denoting as S, I know this is a strange symbol to use, but that's what we're going to use, is S, is equal to the measure of the arc divided by 360, so some fraction of 360, multiplied by the circumference, 2 pi r. So the arc length is a fraction of the circumference. We need to know how to work in terms of pi. We are going to have a fraction of that circumference. Our calculators are going to do this work. We're going to type everything except for the pi button to do this symbolic math, right? Our calculators can't do the symbolic math, but it can do the computation. It can take this and divide by that, multiply by 2, multiply by r, and give us a number of pi units, all right? And that's what we're going to do for this. You can write it as a proportion if that makes sense to you, but I think that if we have this formulaic understanding, things will work out quite well for us. So for these items, go ahead and draw those pictures to the best of your ability. We're going to find the length of this arc in terms of pi. The measure of this angle we know is 90 degrees. That means the measure of this arc is 90 degrees. So the arc length, S, is equal to 90 over 360, which is 1/4, of 2 times pi times the radius. If the whole thing is 16, then this part is 8, and that part is 8. So we're going to do 1/4 of 16 pi is going to give us 4 pi, and then we're going to use our units, inches. That is the length of arc XY. If you want to use S for that, that's fine. If you don't want to use S for that, then we can write out the length of arc XY. I would like for you to try this one. This whole arc is 240 degrees, right? This whole pink thing right here, right? This is 180, and so this is what's left over. We can know what that is if we needed to, but our job is XPY. This whole thing is 240. How are we going to write this formula down? Right? Plug in the numbers, execute the operation with units. You try that one. Example, we're going to call that 3B. How's that? All right, that's the end of our lesson for part 1. All right, we're just finding that arc length. We'll confer about those items that you did on your own. Make sure that we can use our calculators to do those things. Let me know if you have questions.